Hi everyone, my name is Neha and this is the ninth lecture on Introduction to Automation. In this lecture, we are going to learn about pressure sensors. Pressure. Pressure is defined as the force per unit area that one material exerts on another. And the pressure sensor, it usually consists of two parts. First part converts the pressure to a force or displacement, and the second part converts the force or displacement into an electrical quantity or electrical signal. Now, the SI unit of the pressure sensor is measured in newtons per square meter, which is also called as Pascal. And here on the picture, you see digital air pressure sensor, and that's how it looks like. Next, we are going to see the applications of the pressure sensor. So the pressure sensor, it can be used in measuring the inlet, outlet, or system pressure in the engine test setup. They can be used to measure fluid height or level in the tanks. Multiple pressure sensors can be attached to pipes either above or below ground to help detect a break or leak in a pipe. Next, we have identifying a gas leak with the pressure sensors. So in this one, if you want to detect a gas leak, you will need a reference pressure against which to measure the pressure that is going into the tank. And if the pressure goes down, then the output will go up, indicating that the presence of a leak. Next, we have monitoring flow rates with the pressure sensors. And in this one, differential pressure sensors are the one which are the most common ways by which you can measure the flow rates. And here on the left is a picture of a digital air pressure sensor. Now next we have these three different pressures: gauge pressure, differential pressure, and absolute pressure. Gauge pressure is the simplest pressure, and it can be measured by taking the difference between the measured pressure and the atmospheric pressure. Atmospheric pressure is usually at 14.7 psi. Next we have differential pressure, and differential pressure, it is a difference between two places where neither pressure is necessarily going to be atmospheric. And the third, we have absolute pressure, and this third type of pressure, it can be measured with the differential pressure sensors, where one side is referenced at a 0 psi, which is close to a total vacuum. Now next we have different types of pressure sensors, and these are the three pressure sensors which we are going to study in this lecture. First is the Bourdon's tube, second is the bellows, and third is the semiconductor pressure sensor. So let's begin with the Bourdon's tube. So here you see two types of Bourdon's tube. One is the unbent type and another one is the untwist type. And this Bourdon's tube, it is a short tube which is closed at one end. So you can see this end is closed, and similarly here this end is closed. And the other end, from the other end, you will basically send the pressure, and similarly here the pressure will go from here. So what will happen when the tube is pressurized, it tends to straighten out. You can see when there was no pressure in this tube, then the profile of the Bourdon's tube will look like this. And once the pressure is increased, then the Bourdon's tube, it will try to straighten up, and in the high pressure profile it will look like this with the dotted line. So this motion you see here is going to be proportional to the applied pressure. The motion of the Bourdon's tube will be proportional to this applied pressure, and we see that here at this end LVDT is connected, and you know that LVDT converts the displacement into an electrical quantity. So the change in the displacement here, it will be sent to the LVDT, and LVDT will change the displacement into an electrical quantity, and at the output we get the change in the pressure in terms of electrical signal. Now this displacement, it can be either linear or it can be angular also, but in both the cases we can measure the change in the pressure in terms of electrical quantity. Now this Burden's tube sensors, they are available in different pressure ranges, which range from 30 to 100,000 psi, and they are typically used in steam and water pressure gauges. And here on the right you see the real picture of the Burden's tube pressure sensor. Now next is the bellows. So this sensor uses a small metal bellows to convert the pressure into linear motion, and as the pressure, you can see here, these are the two pictures. This is a single pressure type where the pressure is applied just from the bottom. And in the second picture, you see this is the differential pressure type, and in this one the pressure is applied from the top and the bottom. So this is your pressure 1, this is your pressure 2. Here the pressure from outside the bellows, which is pressure 2, it will tend to make the bellows compress, whereas the pressure 1, it will tend to make the bellows expand. And this the shaft, the position of this shaft, it has a function. It has a function of the difference in providing the difference in pressure inside and outside the bellows. Let's see this example picture in which a bellows pressure sensor is there, and we see that this is the inlet from where the pressure will go inside, and spring is provided, and we have bellows here, and then we have this sector which is connected to the gear, and as this sector moves the gear will change, and further it is connected to this needle, and this needle is connected to this scale. So let's see what will happen when the pressure inside this increases. Then the bellows expand against the resistance of the spring, and the motion is detected by the position sensor here, which can be potentiometer or LVDT. So let's say we have here a potentiometer. So from this potentiometer we can see the change in the motion in terms of electrical quantity. So this is the working of a bellows pressure sensor, and these bellows pressure sensor, they are capable of they are very sensitive when compared with the Burden's tube, and they have low pressure range of 0 to 30 psi. And these bellows are most often used to protect the critical components. They can be used in chairs, buses, walls. They have industrial application also, for example in gas industry, as they can be used. They can also be used in subsea controls, in fluid management, etc. Now let's see next pressure sensor, which is the semiconductor pressure sensor. And some commercially available pressure sensors use the piezoresistive property of the silicon, and the pressure range for the semiconductor pressure sensor is from 0 to 1.5 psi to 0 to 5000 psi. And in this a piezoresistive element is used, and it basically converts the pressure directly into the resistance, and that resistance can be converted into the voltage. So you see here, from here the pressure is applied and vacuum is applied from here, and then we have this piezoresistive element in between. So this type of sensor have the advantage of no moving parts, and they are available in different pressure ranges you have already seen. And the example for this type of pressure sensor would be a commercial semiconductor pressure sensor, which is ST2000 series from Sensem. And this semiconductor pressure sensors, they are engineered to handle complex and sometimes harsh gases, and they outputs a voltage which is directly proportional to the absolute pressure. Now next we are going to see the problems based on pressure sensors. So let's see this one. A differential pressure bellows sensors is receiving 4 psi gauge, which is a gauge pressure, on one side and 12 psi absolute pressure on the other. What pressure does the sensor reports? So to calculate this, we need to first find the measured pressure, and that can be calculated by this formula, which says gauge pressure is equals to measured pressure minus ambient pressure. And ambient pressure, you know that it is 14.7 psi. So we will put the values into this equation. Here we're going to put 4 psi, and here we're going to put 14.7 psi. So if you put that, you will get the measured pressure, which is 18.7 psi. And now we have to find out the difference. So we will find out the difference between this pressure and this pressure. So difference will be this, and between these two pressures, and the difference will come out to be 6.7 lb per square inch. So this is the answer for this problem. Now let's see another problem. Differential pressure below sensor is receiving 20 kilopascal, which is a gauge pressure on one side, and 90 kilopascal absolute pressure on the other side. What pressure does the sensor reports? So this problem is also similar to the previous problem. You will be using the same formula. The only difference is that the unit is in kilopascals. So you will put that value here. So 20 kilopascal is our gauge pressure. We have to find a measured pressure, and ambient pressure we already know, it's 101.3 kilopascal. So you will put these values and you will find the measured pressure, and which is going to be 121.3 kilopascal, and the final difference pressure is going to be the difference between this and the 90 kilopascal. So you will put these values and you will get 31.3 kilopascal. So this is the end of the lecture. Thank you so much for watching.